Welcome to our third and final lesson on area. This is going to be on composite area. For the last couple of lessons, you learned how to find area of simple shapes. And this time we are going to do composite area. So in other words, we're going to combine or subtract two or more shapes. So for instance, there are two ways of identifying composite area. Alright, the first type is where you combine two different shapes into one. So if you look at this, we have a triangle and we have a rectangle or square, and we can find the total area of these two shapes by finding the area of one and find the area and of course combine it. That is one type of composite that you can have. And a second type is where you take a shape such as this and you've got to find this total area, but you'll notice that we've got a hole or another shape that's cut out. And so what we're going to do is we'll use subtraction in order to find this area here. So that's what we're going to look at. Some of these problems I'm going to show you are pretty straightforward and simple, and a couple of them it does take a little extra work to solve it. Our first composite shape is apparently of a semicircle and a trapezoid. So in order to find the composite area of this total shape is that we're going to have to find the area of this semicircle, and we'll need to find the area of this trapezoid, and of course add these two answers together to get our total composite area. So let's begin with the semicircle. Well, first of all, let's write down the formula of a circle. Formula of a circle is area is equal to pi r squared. Well, this is half of a circle. So the area of a semicircle would be pi r squared divided by 2. Alright, let's see what we have. We have pi, and now we need the radius. Well, 18 is the diameter, so it's going from one end to the other, so that's diameter. In order to get the radius, of course, we'll divide this by 2, and that will give you 9 squared. And then we divide the whole answer by 2 in order to get the answer to the semicircle. Now, when y'all are working these problems, we're going to round everything to one decimal place. So let's take our calculators and let's figure out the area of the semicircle. Actually, let's turn it sideways so we can get the emblem or symbol for pi. To keep you from having to press 3.14 every time, we're actually going to use the pi button that's on the screen of your calculator when you turn it sideways. So we are going to multiply pi, so let's press pi, times 9 squared. 9 squared, of course, is 81, equals, and then divide it by 2. We get 127.2. So 127.2 is the area of the semicircle. Now, let's find the area of the trapezoid. Thinking back from our area 1 lesson, the area of a trapezoid is 1/2 b1 plus b2 times the height. So that gives us 1/2, b1 is 18, plus b2, 24, times the height of 10. 18 plus 24 gives you 42. A couple of ways you can go about this. You can say 42 times 10 divided by 2, or half of 42 then times 10. It doesn't matter. It gives you the same answer. So if I do say 42 times 10, you get 420, and then you divide it by 2, you would get 210. Now 210 is the area of the trapezoid, but that's not what we're looking for. We want the composite area. So we're going to add 210 plus the 127.2. That gives you 337.2 units squared. And that would be the area of this composite shape. Every year when I give this shape as an example for students to work out, I have students trying all kinds of different ways of trying to solve this. Some students try to figure out doing maybe the Pythagorean theorem, some say maybe trig, but actually this problem is going to be the most simple one that you're going to do out of this assignment. Because if you look very carefully, we actually have two common shapes. If you look here, we have a parallelogram. And then if you look here, you have a triangle. Well, if you find the area of this parallelogram and the area of this triangle, add these two together, you'll have your composite area. Well, let's look at the parallelogram first. Remember, area of a parallelogram is base times height. So we would have 10 times 7, which is 70. Yes, that's it. That's all you have to do to find the area of the parallelogram. Now, let's find the area of the triangle. Remember, on the triangle, you need the two numbers that connects the right angle. So I have a 7 and a 12. So the formula for area of a triangle is 1/2 base times height. So this is 1/2 12 times 7. Well, take this, 12 times 7, divide by 2, and you get 42. Well, that's not our final answer because remember we want composite, so we are going to find the total area of these two. So you just simply add 70 plus 42 and you get 112 units squared. And that would be your composite for this shape. Our third shape is actually going to probably be the one that you're going to have to do the most work for or with. And here we have a composite shape. And if you look very carefully, we have actually, if you look at it, you could actually break this up to a triangle and I guess a trapezoid, or you can have a rectangle and a triangle. I believe this is going to be our best bet in order to finding the total area. So let's go ahead and find the easy one, the rectangle. We all know that the area of a rectangle is base times height. So we're going to have 10.5 times 26.5. So let's get our calculators out and let's go ahead and multiply 10.5 times 26.5. That gives you 278.25. We're going to round everything to one decimal place. So that's what I want you to do when you work the problems on your assignment. So 5 means we're going to round this 2 up to a 3. So 278.3. And this is the area of the rectangle. Now here's where it gets a little tricky. We need to find the area of this triangle. And the only number they give us is the 34.5, which apparently is a hypotenuse. But we don't need that number. What we need is the two numbers that are connected to the right angle. So in other words, I need this side and I need this side in order to complete area equals to 1/2 base times height. Alright, so let's see what we do have. 45 is from here to here. 26.5 is from here to here. Well, if you just simply take 45 and subtract 26.5, you're going to get 18.5 right there. Alright, let me write that down for those who need to see it again. 45 minus the 26.5 gives you the 18.5. Alright, now I need this number. Well, I've got 10.5, but I have no idea what this is. We don't know if this is halfway up or not. A lot of students will say, well, if that's 10.5, that's 10.5, but we don't know that. So what we're going to have to do is the Pythagorean theorem. Yes, so we have a squared plus b squared equals c squared. We're going to call this a. So this is a squared plus 18.5 squared is equal to 34.5 squared. All right, let's take our calculators. 18.5 and we square it. You get 342.25. Now I want you to keep your decimal here. It's just that when we find sides and all that, we're going to go one decimal place. And then over here we got 34.5 squared. And this is going to be 1,190.25. Subtract the 342.25 from both sides. And you'll get 848. So a squared is equal to 848. Now let's take the square root of that. So remember, the square root button on your calculator is going to be right there. Take the square root of 848 and you get 29.1. So 29.1 is the height. So this is 29.1 for the whole height here. Now I can find the area. So 1/2 base times height, and let's see what we get. So 29.1 times 18.5 divided by 2, and we get 269.2. This is the area of the triangle. Now, since this is composite, we need to add the 269.2 with the 278.3. So 269.2 plus 278.3 equals 547.5. And that would be our composite area. So take these two and add them up. All right, so we went on and got that one out of the way. It is going to be the more difficult one that you're going to see on your assignment today. Now, our third one, or fourth, this is a composite area where you have a part that's cut out. And a lot of times when you see these problems in books or on different sites, they will actually say, what is the area of the shaded region? So in other words, how much area is this? Anytime you have something that's cut out, then that means instead of adding the two areas together, you're going to subtract the two areas. So we have two formulas. Here's the triangle, 1/2 base times height, and then the semicircle, pi r squared divided by 2. So find the area of this, find the area of this, subtract, and then we have the remaining area. Well, the triangle looks like it's going to be pretty simple because we have our right angle. So that's going to be our base and height. So I have 1/2, 10 times 7. Okay, 10 times 7 is 70. 70 divided by 2, so you get an area of 35. This is going to be the area of our triangle. Now, let's find the area of our semicircle. Please be careful with this. This is not the radius. Of course, that's the diameter. The radius is half of that, which would be 2. So this would be 2 squared and then divided by 2. All right, let's see what we get. Remember, we're going to turn our calculators sideways so we can access the pi button. So I have pi times, we have a radius of 2 squared, which is 4, equals, and then divided by 2. So our area of the semicircle is 6.3. 8's going to bump that 2 to a 3. So this is 6.3. Area, semicircle, 6.3. Now, what we need to do is take this semicircle out from the triangle. So we're going to have 35 minus 6.3. And that gives you 28.7 units squared. And that's how you find the area of this shape. Our fifth shape is a circle with a trapezoid cut out of it. So we want to find the area of this shaded region, this part that's shaded. So what we got to do is find the area of the circle, which is pi r squared, and we want to find the area of this trapezoid, which is 1/2 b1 plus b2 times the height. And once we find both of these, we subtract, and that will give you the area of the shaded region. So let's find the circle first. So this is pi. Now the diameter is 30. Since this is 30, the radius is going to be 15. Now don't divide that one by 2, because notice that we do not have a semicircle. So this is a circle, so just pi r squared. Alright, now let's take 15 and square it. You get 225, and then multiply it by pi. So times the pi button found on your calculator, and we get 706.9. On your calculator you'll get 0.85, so remember, take that 5, round that 8 up to a 9. So 706.9 is the area of the circle. Now let's take out the trapezoid. We have 1/2 b1 plus b2 times the height. b1 plus b2 is 52. Alright, take the 52, multiply it by the 18, you get 936. Divide that by 2, and you get 468. Now 468 is the trapezoid, and we want to cut it out, so you just subtract. So 706.9 minus the 468, and you get 238.9 units squared, and that's the area of that shaded region. For our last shape, this is one of my favorites. On this shape we have a looks like a square with 4 circles cut out, and we want to find the area of this shaded region. So how much area is being incorporated? Now notice there's only one number given, 16. That's all we need in order to solve this problem, because if you look, we have 4 identical circles. Since we have 4 identical circles, this is not going to be as difficult as you think, because when you stack these 2 circles together, you get 16. Well, look what you have here. You have the same 2 size circles stacked here, which is also 16. So I have an area of a rectangle or square, base times height, or s squared, and then I have these 4 circles. Now how are we going to find the area of the circles? Well, it is pi r squared, and we have 16 going from one end to the other. Well, if these circles are identical, and therefore these 2 diameters would be 8 and 8. Well, if the diameter is 8, that means the radius is 4. So in each of these circles we have a radius of 4. Alright, now let's find the area of our square. 16 times 16. You get 256. So this is the area of our square. So that's what we're going to be taking away from in order to find the area. Now let's find the area of our circles. Well, let's just do one circle, and then we're going to end up multiplying it by 4 because there's 4 of them. The radius is 4 squared, so this is pi times 16. So let's turn our calculator sideways. 16 times pi equals, we get 50.26 or 50.3. Now 50.3 is one circle. Alright, I don't want one circle, I need 4 circles. So we're going to multiply this by 4. So let's take 50.3, multiply it by 4, and we get 201.2. That is for all 4 of these. Now we take the area of our square and subtract the area of our 4 circles. So 256 minus 201.2 gives you 54.8. And that would be the total